Okay, hello everyone. Hope you guys all had a restful and safe spring break. Now, unfortunately, it does look like school will be closed for a little bit longer, so we will keep doing online learning for at least the next couple of weeks. So I will keep making videos and posting assignments for you guys to complete. And today we're actually going to start our very last unit, Unit 9. It's rational functions. Now, as I go through this, please go ahead and take notes, either in your notebook or on a piece of paper. And let's go ahead and get started. Okay, so what is a rational function? So a rational function is a ratio of two polynomials. Okay, so a ratio, you might remember from before, when you did ratios in middle school, ratio means division. And polynomials, we did a whole unit on that in the first semester. So for example, what is a rational function? Let's look at some examples. So for example, let's say we have x plus 2 over x plus 5. This will be an example of a rational function because this is division, right? Fraction is division, and both of these are polynomials, x plus 2, x plus 5. Another example will be, let's say, x squared plus 3x plus 1 over, let's say, 2x. Okay, again, this is division, and both of these are polynomials. So then this whole thing is a rational function. Okay, so how about examples of something that's not a rational function? So not rational function. And we can come up with plenty of these as well. So let's say we have square root of x over 3x squared or something, right? So this one is division. However, the problem is this guy on top, square root of x, this is not a polynomial. So then that means this whole thing is not a rational function. Or we can do something like, right, we can even do log of x, right, over, let's say x. Again, this top, we just did logs, but logs is not a polynomial, so this whole thing will not be a rational function. But we will be spending, pretty much the rest of the year studying rational functions. And there are really 3 parts to this. So there's going to be part 1, which we're going to start with, and that's operations with rational functions. And then we're going to have some solving rational equations. And then finally, we're going to do graphing. Now, typically with all the other functions, we've done graphing first. Now, graphing rational functions is actually a little bit complicated. So we're actually going to do that last. Hopefully, we're going to resume classes by then. So then that will be what we'll do last. But we will start with operations and solving. And by operations, I mean things like multiplying, dividing, adding, and subtracting. Solving, we've done plenty of times before. We're going to solve for x or solve for any variable. And then, of course, graphing. And as we saw in the last couple of units, we're going to have more asymptotes when graphing rational functions. But here's what we're going to start with. We're actually going to start with operations. And today we're going to talk about how we can multiply and divide with rational expressions. And actually, it might seem counterintuitive, but multiplying and dividing is actually much easier than adding and subtracting, which we will see probably next week. Okay, so let's go ahead and get into multiplying and divide. But before we do it with rational functions, let's just go ahead and do it with numbers. So when you guys learn how to multiply and divide fractions, probably in elementary school, right? So one way you can do it is to simply, multiply the top, multiply the numerator. 5 times 8 is 40. And then multiply the denominator, 6 times 15. I think that's 90. And then, of course, we can simplify. We can divide these by 10, divide by 10, and we get 4/9. Okay, but there is an easier way where we can multiply fractions. So let me erase that way. is we can actually simplify first before we multiply, right? So here's what I mean, and hopefully you guys remember this. We can do something called cross-canceling. So for example, 5 and 15, we can divide them both by 5. So then I get a 1 here. 5 divided by 5 is 1. 15 divided by 5 is 3. And then similarly with 8 and 6, I can divide both of these by 2. So I get 4 here, and then 6 divided by 2 is 3. And now let's go ahead and multiply what's left. So I get 1 times 4 is 4, and 3 times 3 is 9. So we get the same answer, but doing it this way, which is the way we're going to do it with the rational functions, usually means that, or usually will make the problem much easier because we're working with much smaller numbers. Okay, so that's multiply with fractions. And then let's go ahead and take a look at how we can divide with fractions. Now, when we divide fractions, there's actually one step we should do first, right? So for those of you that remember, when we divide fractions, we're going to change it to multiply by the reciprocal. Okay, so instead of 12 over 7 divided by 18 over 21, we're going to change it to multiplication, but then we're going to flip the second fraction. So we're going to make it 21 over 18. It's called the reciprocal. And now from there, the rest of it is the same as the one we did before. So now 12 and 18, we can cross cancel. We can divide it by 6 in this case. 6 is the largest. So 2 and 3. 7 and 21, we can divide by 7. So it becomes 1 here, and it becomes 3 up there. And now we can actually keep simplifying because we have these 3's up here, right? 3 divided by 3, we can simplify again. We can divide those by 3, so it become 1 and 1. Okay, so then at the end of the day, we have 2 times 1 over 1 times 1. So 2 over 1, which is just equal to 2. So our final answer after we simplify everything would just be 2. Okay, so if that rings a bell for you guys when you multiply fractions with just typical numbers, then let's go ahead and look at multiply and divide with rational expressions. And the idea is very much the same. So let's go ahead and take a look at a few examples. So let's see, we have 2x over 8 times 10 over 5x squared. Right, so let's first see what we can do with the numbers. So I notice a 2 and an 8 here, right? So those we can simplify. 2/8, we can divide it by 2. I get a 1 over 4. And then I can do the same thing over here with 10 and the 5. I can divide those by 5. So I get a 2 and a 1. And then I see I still have a 2 up here and a 4 in the denominator. Well, those I can divide by 2 again. So I can get a 1 on top and a 2 on the bottom. So I think that's it in terms of the numbers. But then, of course, we still have the variables. Well, x, what can I do with x and x squared? Well, I can divide them by x, right? So if I divide x by x, I get 1. And x squared, here I've got 2 x's. If I divide out by an x, I still have 1 more x remaining. So then let's go ahead and multiply the rest of what we have. So everything on top becomes 1. And on the bottom, I have a 2 times 1 times x. And that's 2x. Okay, and that's it. So not much different than multiplying with just numbers. We can first simplify and then multiply. And let's look at one with division. Again, same idea as above. We're going to change it to multiplication, but then we're going to make it the reciprocal. So 5p over 3. Okay, again, whenever you have division, we're going to multiply by reciprocal. Okay, and now let's go ahead and do the simplifying. So I'm going to focus on the numbers. So I have a 6 and a 3 here. I can divide those by 3. It becomes 2 and 1. And then I think that's all I can do with the numbers. I've got a 2, a 5, a 7, and I can't really simplify with those numbers. So I'm done with that. But of course, I still have the variables, the p's. Now I can take off this p and this p. I can divide those by p. I get 1 and 1. And I think I am done. So on top, I have a 2 and a 5. So that's 10 p cubed. And then on the bottom, I just have 1. So 10p cubed over 1, or just 10p cubed. And that's it. All right, let's try a few more just to get the hang of this. So again, we're still working with rational functions, but this time we have things that are kind of more complicated. But the idea is still the same. So let's take a look. I'm going to look at the numbers first again. I notice a 6 here and a 6 there. I can cancel those out. Divided by 6, get 1 and 1. And I think that's it in terms of the numbers. But let's look at the variables now. Now I see I have a k minus 2 here and a k minus 2 up there, right? Those we can actually treat them as one big piece. So those actually we can cancel out as well because they're the same, right? K minus 2 over k minus 2. We can divide them by k minus 2, and those will cancel out to be 1 nicely. And then I think that's it. That's all we can do. Now, you might say, why can't we cancel out these k's? Because I have a k and a k. And the reason why we can cancel those out is because they're both on the denominator, right? So we can't, make those equal to 1s, whereas these k minus 2s, this is k minus 2 divided by k minus 2. So those we can cancel out because they're being divided. But these k's on the bottom, they're being multiplied together. So those we cannot cancel out. So then let's go ahead and see what we have left. On the bottom, I have k and k, so that's k squared. And on the top, I have 9 times k plus 1. Okay, and then a very common mistake that students might make is they'll cancel out this k here and then cancel out one of these k's at the bottom. Okay, now this we actually cannot do because this k plus 1 is actually, this is an addition, right? K plus 1, it's not k times 1. So when things are being added, we can't cancel that out with something that's being multiplied at the bottom. Okay, so even though they both have k's, there's actually nothing else we can do in this case. So this is actually our final answer. There's nothing else to be simplified. And then let's try this one with division. So again, same deal. I'm going to change it to multiply by the reciprocal. So this first guy stays the same. Now this becomes x plus 1, x plus 3 over 10. And then again, let's go ahead and do our canceling. So I've got a x plus 3, x plus 3. Those will cancel out to be 1s. And x plus 2, those are also the same. I can cancel those out to be 1s as well. And I think that's it. I've got x plus 1 over 10. All right, I think I've got 2 more to go. So let's go ahead and quickly go through these as well. So this is already a multiplication. So let's see what we can do. I see a 4 and a 10, right? So those we can divide by 2. So I get a 2 and a 5. And now let's look at the variable terms. Now this m plus 2 squared, right? This just means I'm doing m plus 2 times m plus 2. So we can put it like that so we can see it a little bit easier. But now I see that I have an m plus 2 here, I have an m plus 2 there. And then I think that's all I have. So let's go ahead and write what's left. So on top, I have 2 times m plus 2. And on the bottom, I have a 5m. Oh, actually, we can also cancel out the m's, right? So we have an m up here and an m up here. So those m's can actually also cancel out to be 1s. So then on the bottom, I just have 5 times n minus 5. And again, it's very important that we cannot cancel out those m's because they're not terms by themselves. They're part of larger terms, right? So this is really n plus 2, and this is really n minus 5. So those m's are not separate. They're together with something else. They're both binomials. So those we actually cannot cancel. And this is going to be our final simplified expression. All right, and then let's look at the last one. Again, this is going to be division. So I'm first going to rewrite this as multiplying by the reciprocal. So 12 over m minus 8 over 8a squared over a plus 4. Okay, now this looks pretty, complicated, but again, the idea is going to be exactly the same. I'm going to first start with the numbers. So I see a 12 and an 8. I can divide those by 4, I think. So I get 3 and 2. And then let's look at the variables. So now I see an a minus 8 and an a minus 8. There's also an a minus 8 over here, but I can only cancel out one at a time. So the one that I highlighted will have to stay. But let's see what else we have. I have a plus 4 and a plus 4. Those will cancel out to be 1s as well. And then let's see what else I have. I think that's all I can do, right? These a and a squared, those are on the same side. They're both in the denominator. So those I can't really do anything about. So then let's go ahead and write our final answer. On top, I have a 3 and an a minus 8 that we highlighted. On the bottom, I have a 2, and I have a and a squared. So if I multiply those together, I get a cubed. And I think that's all we can do. Once again, these we cannot cancel out. We cannot simplify because the top, this is a minus 8. So that's part of a binomial. It's not just the a by itself. Okay, so this actually is going to be our final, most simplified form. Okay, so that is it. Please make sure you're copying these down as you watch the video. And once again, please, of course, let me know if you have any questions. I will be posting an assignment for you guys to work on as well. And other than that, I hope you have a great rest of your day, and I'll see you guys next time.